All right. So first of all, thank you for the good introductions, and then we are very happy to share our work with all these people. So let's get started. All right. So here's our pretty much the motivations and the significance is about natural or man-made disasters. So here's we have a couple of examples. So for let's say, so we have such an earthquake happens. It's like a long time ago, but this earthquake affects many neighboring states in 2016, and then. So we also have such a hurricane every summer. So pretty much in the Florida, in such a south area, so pretty much suffer from such a hurricane and then following flood. And also we have such a wildfires in the California area. So pretty much more than 7,000 wildfires in 2019. So, but as you can see, so such a disasters, man-made disasters, pretty much it occurs in a very flash, in a very short time, but it has very wide impact to our infrastructures and then community. So pretty much the size of this impacted area, so pretty much from a few miles to the several states. So it is very serious. So that once the disaster occurs, what should be done? So pretty much we focus on expedited search and then rescue plan. But actually it requires very accurate predictions. And then, so as you can see, every year pretty much we have such a lot of disaster happens in US. Okay, but as you can see, it happens very short time, but its impact is very huge. So pretty much impact on our infrastructures and the community. So pretty much size of this impacted areas are ranging from a few miles to the several states. So here's pretty much once we have such a disasters, so what do we really need? So pretty much we need such accurate predictions of the locations, target locations we are going to rescue. And then we need such an accelerated real-time manner rescue decisions. So pretty much we have to protect such a golden hours. So for example, so the survivors should be treated, treated within 1 hour. Otherwise, so their survivors probability is significantly decreased. And also, so we have to expedite and the rapid such an execution of these operations. So here's our primary research motivation is once the rescue teams arrives in the disaster site, and then what should be done? Okay, so pretty much they will consider so where to search first, and then where to allocate such a very limited rescue resources and the manpowers. And then so they have to make a decision. So which area should be searched first? So that means they have to have such a rescue priority. Okay. So those issues pretty much happens, and then in reality, okay, so pretty much as you see, so such a impacted area, such a huge, pretty much our infrastructures in the community, so pretty much easily collapse. So that such a rescue teams cannot see clearly such a disaster site. Okay, so that definitely, so they will have such a delay. So before starting the rescue decision and then operations. So this is pretty much serious, and then this will really lose hours of golden hours. But actually, we have such a traditional search and then rescue operations. But however, so pretty much, so those traditional approaches heavily rely on limited manpowers and then resources. And then such a rescue resources are so expensive, and then sometimes it is not inefficient, and then time consuming. So here now these days, so we have such a UAV, unmanned area vehicle-based the rescue and the search operations. So commercially well known and drone. So pretty much drone-based search and the rescue operations are rapidly emerging as the alternative way to rescue and then search. So, but the thing is, so each rescue crew and the rescue teams, so probably most likely they are not professional drone pilots. So because of that, even it would take a time to prepare and then before launching, before initiating any operations. And also, so it is not efficient because so they are going to simply look at the monitors and then manually so navigate such a drone. So pretty much this drone will scan or search the area. It's like blindly. Okay? And also, in a very important moment, professional drone pilot may not be available. But as you can see, our impacted area, the size is huge, so that we may not have all the professional and drone pilot available. Okay? And also our motivations and the research motivation is pretty much well aligned with this current homeland security missions. But as you can see, we have five major missions in the homeland security. But as you can see, one of mission is ensuring such a resilience when the disasters happens and then occurs. So pretty much our research is targeting so for this last homeland security missions. Okay, so hopefully we can present some potential solutions for these missions. All right, so here pretty much our approach is that so we try to answer those questions. So once the rescue teams arrives at the emergency site, right? Then how can this rescue crew quickly respond to such a disasters? And how quickly so they are going to conduct such a drone-based search and then rescue operations? And then because of this drone, every rescue crew have to be a professional drone pilot. So is there any way so any general rescue crew can conduct such a drone-based operations? So we try to answer so those three very general questions. So here our solution is, so we try to propose such a small-scale prototype of a framework. So for the proof of concept. But here so we try to have such a very small-scale prototype first. So that our goal is, so we are going to support such a drone-based search and the rescue operations. And then more importantly, so we are going to reduce such a setup delay before initiating any drone-based search and the rescue operations. So we are going to automate any drone-related operations so that even any general rescue crews can conduct so this drone-based operations. So this is our main goal. So here, so we are going to present these two tasks to achieve this goal. So one is a public map-based point of interest extraction technique, and the other is a two-step population-aware path planning. So we are going to explain one by one, but before that, so why don't we give such an overview of our systems and then frameworks. But as you can see, so once the rescue team arrives at the site, okay, so pretty much they know only their own current locations. But however, they may not know such a geographical information of this affected area. They have no idea. Okay, so based on that, we are going to extract some useful information about this area. So we are going to search and then rescue. Right? So this is a public map-based POI extractions, but we are going to explain a little bit more detail. And then, so after that, we are going to have such a population-aware path planning. So pretty much this second task, so we are going to give such an information to the drone, so that these drones will conduct such a scan operations autonomously. But here, so in this project, we are going to produce such a mobile app applications. So pretty much those tasks so will be integrated into such a mobile applications. So in this research and this project, so pretty much we use such a Google Android-based studio and then MATLAB softwares for the simulations and then experiments and then implementations. All right, so first task, so I'm going to hand in to my students, Elora.
So my part in this project is to identify areas of high population where many people will be, and we call them points of interest. Many of the points of interest that we did was shopping malls, hotels, restaurants, and apartments. When I was building the database around Lubbock, Texas, we were able to collect 63 apartments, 21 hospitals, 83 hotels, 675 restaurants, 1,431 stores, and 121 Texas Tech University buildings is within this database. After completing the database, my next goal was to create a Android-based smartphone software app called FastPlan. This is to automate the launch and construct a drone-based operation. And so all the app rescue crew will have to do is just run the app and the drone will work. In our developmental phase, we found 3 areas within Lubbock that we can use to demonstrate our app. Area A is a shopping center with many points of interest. Area B is a small neighborhood area with a few points of interest in it. And Area C is an area that's right off the highway where, as you know, once you come off the highway, there's many buildings right next to it. In these areas, there are the different points of interest. We're allowing the user to be able to separate which type of points of interest they'd like to focus on, such as restaurants, stores, hotels, apartments, Texas Tech University buildings, or hospitals, or even all the above. The user will be able to check mark multiple different things that they want. If they want to just use stores and restaurants, they can do so. As you can see, this is this image shows all the different points of interest and with ranking their population density. The smaller the circle with the lighter the color, the smaller the population density that we gave it. We gave all the points of interest ranking from 1 to 10 on how populated they'll be on a day-to-day basis, such as a small family restaurant will rank lower than a store such as Target will rank much higher. So Area A consists of 63 different points of interest within it. Area B consists only of 9 points of interest that are spread out, though there are a few highly dense points of interest. And Area C, it has only 11 points of interest, but all the highly dense points of interest are clustered together in one area.
And so it was my job to then take those points of interest and figure out how to efficiently cover those points of interest and give a path to the drone that would be able to cover all these points of interest. And to do this, I split it up into a 2-step process. The first process was to then take those PUIs and group them together with a clustering algorithm so that it would significantly reduce the amount of scan points that the drone would have to go to, because the scan points would include multiple points of interest within them. And then also to then make a path planning strategy for the drone to visit all these scan points that will eventually cover every single PUI. So this is kind of a demonstration of how we started off. We first started by extracting the PUIs, and this is demonstrated here. And then we started to cluster the PUIs together in these coverage areas that will then be able to reduce the amount of scan points that the drone will eventually go to. I think we start with 100 points of interest in the top left, and then reduce it down to, I think it's 32 scan points after the clustering. And then we, for visual sakes, remove everything except for those 32 scan points that the drone will eventually visit. And this will allow us to make the path for the drone. And we started off by just making a random path that the drone would have to follow. But then we wanted to find a way to better make the clustering and the pathing more efficient, and that's what I started to work on. And so with the extracted POIs and clustering, we decided to find a way to cluster them better. And to do this, we used a split and merge based clustering that will be better equipped to handle the highly dense spots as well as the very sparse spots that we found along on the graph. And then we also made a much more efficient path planning that will visit the very dense places as well as take into account the distance that it's having to travel in order to get to those places. And so to go more into the clustering that we have, we start off with talking about the merge part of the split and merge clustering. And this usually happens when we have target points that are very spread out. And normally the clustering algorithm will just start going one by one, finding the target points that are no longer covered or are covered in the coverage areas that have been made. If they are, then they won't be considered for the next set of coverage areas. And so it'll just slowly cluster them, but as you notice, it's a little bit inefficient and that all the areas are all going to be the same size. And there's ways that you could do it that would better cluster them together, and that's what I was trying to find out. And if we did this, we would hopefully be able to reduce the amount of time spent traveling between these coverage areas. And so the first thing we did was to merge them and make a bigger coverage area that would reduce the time spent going between these coverage areas. But on the downside, it would make the photos taken by the drone to be a little bit of less quality. But because it's in these sparse areas, we don't have to worry too much about needing high quality photos. And if we increase the amount of area or amount of target points that these merged areas can cover, we can see that they can very efficiently cover areas that were before covered by 6 different coverage areas down to either 4 or even 1. The next area that we found difficulty was the highly dense areas, and that's where we went into the split part of the clustering. These areas would get clustered before in the same way with these single-sized coverage areas that are very inefficient at covering them, and the areas that are covering a high amount of them, when the drone will go there, it won't be able to take very detailed photos because of just how much is clustered all within that photo. Because of the amount of time that is going to be spent on all these coverage areas will be the same. So these areas that have, say, 1 target point will be a very good photo, but when you're going to these target points that have 25 different target points inside of them, it'll be a very clustered set of photos that you're going to get. And so our idea was to then split those areas into much smaller, well-defined areas that when the drone goes to, it will be forced to spend more time there because there's more coverage areas for it to go to. And then the photos will be much more detailed, so these highly dense areas will be better recorded for the rescue crew to make their decisions. And so that's kind of the 2 steps that I was going through. And for the clustering, the first one that you saw with all the homogeneous coverage areas was our distance and density-based clustering. That's kind of where we started. And we decided to move more into the split and merge clustering algorithm that we had. And we found that this really helped when it came to the coverage areas themselves. The coverage areas, if you look at the top right graph, this shows the distance from every target point to the coverage area scan point that it's located within, and adds all these distances up. And then so every coverage area will have its own distance, add all those areas up, and then those are the distances that you're seeing. And we see that whenever we do our split and merge, that we're getting a much smaller distance. And this is because the overlapping has been reduced. And this will overall make the photos that rescue operators will see much more clear and much less clustered, and just overall better. And then when we went to our path planning, we started out with just a random path that will just go to whatever target point next. And then we went into a density first based strategy, which went to the most dense coverage areas as fast as possible. But we found this was inefficient because it would send the drone all over the map if certain areas were more dense than others, and overall the distance was too high to justify using it. And then next we went to nearest neighbor first. And nearest neighbor first, it did its job, but then there would be some distributions that would cause it to be very inefficient. And our idea was to cover areas that were more dense first. So we found that if we were just going to the nearest neighbor first, that it wouldn't cover areas that were densely populated. And so we decided to mix these two together with a density and distance based path that will prioritize the density, highly dense areas, but also not send the drone all over the coverage areas going back and forth, but instead find a path that has a low distance, but is also prioritizing those highly dense areas. And so with this approach, we found that it reduces the total distance the drone has to navigate, not by too much, because we found that the split and merge, while it did help with some, not fully, and we didn't find that this was the performance matrix that we were trying to target anyways, and that was instead we wanted to do the top right matrix, which was more about into the photos that were being taken, and because the distance usually wasn't off by as much. And then we also found that it quickly covered the most amount of POIs because of these dense areas being targeted by our path planning.
So using a simplified version of the split and merged, the distance-based path planning that Eric made, I integrated it into the application. The first image you see is area A of the shopping center with the 63 different points of interest. And this is it with clustered together. And when you zoom in, you can see that in this area right here, which is where the picture got zoomed in, there are many points of interest that are clustered together in one point of interest. And we take those scan points, which are now the red balloons, as our focus points, and disregard the rest of them because they will be covered because they're in the scan area of each scan point. And then once we have all the scan points together, we then implement the density distance path planning algorithm. We do have a video demonstration, but for some reason Teams won't let us play it. So we attached it to our invitation. So you may watch it on your free time.
All right, so thank you for explanations, Eric and Elora. All right, so for conclusions. So pretty much in our project, so we develop such a very small scale, such a frameworks. So we propose, we present, implement smartphone software. So this is called fast plan. So that pretty much once the rescue crew arrives at the emergency site, so hopefully they can use our software so we don't really need such a professional drone pilot. So simply use our own app applications, and then pretty much the drones will be launched automatically. So that we really accelerated such a drone-based search and then rescue operations. Pretty much we try to minimize or no interactions, physical interactions between the rescue crew and the drone. So pretty much we automate such a drone-based operations. So that is the most important thing. So in this our software fast plan. So here we pretty much our project is highly related and then aligned well. So with this the Center for Accelerating Operational Efficiency in here, and also aligned well. So this U.S. Department of Homeland Security. So for the future work, so we try to extend more our approaches. So here we are going to envision such a personal drone So as the technology develops, so we're pretty much expecting such a portable and then small size, micro size, nano size, such a drone. So pretty much we simply call personal drone. And then we pretty much envision, as you can see in the figures, so this drone and the smartphone ultimately integrated all together. So then, just like everybody just carry the smartphone, so now, sooner or later, everybody will carry his own drone. Okay, so definitely, so this drone, just we mentioned that every user don't have to be a professional drone pilot. So definitely not. Simply carry, and then all the drone-based operations will be automatically conducted based on our program, so that drone will run such autonomously. All right, but as you can see, so we have such a already commercial product. For example, air selfie. So if you can just simply type the air selfie in the Amazon, okay, you can already see it. Okay, such a YouTube or SNS influencers, they just want to take a pictures, a different angle, right? So that this drone just simply autonomously just fly around the users and then take a pictures, take a very funny pictures, actually different pictures. Okay, and also such a micro or nano drone already well deployed in the military applications for the reconnaissance or surveillance such operations. Okay, so in the future world, so we are going to continue. So pretty much smartphone softwares, app application based such a frameworks. But now we are going to consider little more about mobility model of this personal drone. Okay. So pretty much these drones will not going to fly randomly. Okay, so pretty much there must be a way, there must be a helpful way to protect or to help the users. So here's our target application is such as securing borders, so with a personal drone. So now these days, such a border security is more important. But as you can see, so this is one of major missions in the homeland security. So pretty much we are going to apply and then target for such a real applications for this securing borders. Okay. All right, and then finally, so this research cannot be completed successfully without the help and the support of U.S. Department of Homeland Security. And then, so all the people and the staffs in ORISE, and then especially the faculty members and then mentors and the staffs. So in these centers, we really appreciate it. And then also, we do have such a support, our home institutions. So we really appreciate it. And then without their help, so we cannot really complete our project successfully, okay? So any questions? So this is a figures in our Texas Tech University at one of December's. Okay, so we do have a snow once. We do have a snow once in a while.
It's like once every 2 years.
Once every 2 years. All right. Yeah. All right. Okay. So thank you for your attention. And then if you have any questions, so please feel free to ask us. All right, thank you.
Really exciting presentation.
Yeah, really good.
How are these personal drones? Like, is it like, are they used already in military, or people are already purchasing this thing from Amazon to take pictures?
Actually, this IL selfie, for example, for the commercial product is already available. Okay, but the thing is, as you can see, so their comment is like a number of star. Okay, the comment is really, really bad. Okay, so that means still there's a lot of spaces we can improve. But this air selfie, okay, is already available. Okay, so pretty much, so this personal drone just simply fly autonomously, but definitely based on this programmed mobility model. So this drone just simply fly around the users and then randomly take pictures. Okay, and then after finish that, so please come back to the base. So pretty much the users. Okay, and then as the users move, it's like slowly, and then drone also follow. Okay, but actually this technology is not a really new one. Okay, but this is the first approaches. Okay, they try to commercialize it, but still there's a lot of spaces to improve. And then for the military base, military applications such as nano drone, micro drone. But actually, I just simply show the figures of whole net. So this was initiated at the it's like in UK, England, and then now U.S. Army already purchased thousands, more than 10,000 such a small drone. They really deployed, so they're in the battlefield. Okay, so that we really envision that. So those drone is not really to the people. It's like who are the professional drone pilot. So our vision is that everybody is like a non-professional drone pilot. Every user can use, okay, just like we use a smartphone, okay? So here pretty much this is a personal drone, for example, so we can provide such applications for safety. Okay, so for let's say, so when you just simply climbing such a mountain and then and so on, sometimes you got such a trouble, okay, and then you need to rescue. So you are going to show, hey, I'm here, and then and so on. So in this case, so your personal drone simply carried with your smartphone. So this drone just simply jump to the air and then simply blinking, okay, then that's it. Okay, so that means very simple operations we can deploy in such a safety application. So actually we envision a lot of practical applications by using such a drone. So especially we mentioned that it's like in borders. Okay, so we have a very long line of these borders, and then so there are borders. Actually, we really don't know what happens. So pretty much such a border patriot. So they just simply drive slowly and then pretty much check every border and then and so on. But in this case, why don't we just deploy such a drone as well? And then so this drone can help so this border patriot, and also this drone can have such a new information. For example, it's like a take pictures and then a little bit more wider or different view. So this drone can provide. So that pretty much the users will be get such a benefit so from the drone. Okay, so that actually we started this research. Pretty much we try to change such a fundamentally change such a research concepts. Actually, in the before, so drone just simply considered as the bad thing. Okay, hey, just this drone just simply invade our property. And then this drone just simply invade such a restricted area and then so on. But now we consider this drone as a good guy, right? So pretty much this drone can help. Drone can protect this user's privacy. But actually one of our the journal papers published in the last years. So pretty much the title is Drone Helps Privacy. Okay, so pretty much it's a little bit contradicting. Yeah. The thing is, based on by using this drone, so we try to protect, for example, the user's location privacy. Okay, but actually there was a lot of the research literature. Okay, so there are so many ways to protect this user's location privacy. But okay, by adding, for example, such a personal drone, is there any ways? Is there any enhancements we can further protect this user's location privacy? So there are so many the areas, untouched area, so we can improve more. Okay. Yeah. Any further questions? Yeah.
It's not a question, but kind of concern.
Yes, yes.
I mean, everybody has their own drone.
Oh, that's right.
Around there and walking, and I don't know.
That's right.
So that is going to be a problem.
Right. So that means this is exactly the same as when we have a drone taxi. Is right. So that means every company has their own drone taxi. So that means there must be regulations and the rules, right? So that means technology actually the grows very, very fast, but actually such a rule and then standard and then such a regulations pretty much is like a slow. Okay, just like many AI applications currently we are facing with. Okay, so we believe, okay, such regulations, so those ethics especially, so ethics will follow. Okay.
I also imagine that when you're far away from the drone and then connection will just get disrupted and that it will rain drones.
Okay.
You know, so, you know.
The FAA has had a lot of,
Personal drones, yeah.
the FAA has had a lot of discussion about UAVs, unmanned aerial vehicles, sorts of things, and you have some regulations. I suspect it's likely the company tried to push for personalized drones. I mean, you see this even with drone delivery. They've been very reticent about sort of allowing people to do that to market too. So the FAA does have pretty tight control of the airspace. So it'll be interesting to see what things they open up.
I mean, for your information, actually, so now there's a regulations for every it's like a laser drone. Okay. So whenever this drone fly, so this drone supposed to broadcast a beacon message. So that means this beacon message will include unique ID of this drone. So because, for let's say, what if this drone just like approaching closer to the airport?
Yeah.
So this is not good. So that means automatically such a very critical infrastructures, they exactly know. Okay, so which drone is like currently approaching. And also this drone, once this drone just simply approaching those critical infrastructures. So definitely these critical infrastructures will reply back, hey, you are not supposed to be here. So that means automatically, so this warning message will be back to the users.
It's gotta be right.
Yeah. So that is one of the regulations. So that means periodically each drone have to be broadcast beacon message, including the unique ID.
It's either during late Obama or early Trump administration, where the NSA guy flew his drone into the White House airspace.
Oh, right.
Yeah, trying to impress his girlfriend. He worked for the NSA. Yeah, he doesn't work there anymore. It's an interesting story you can go find.
I know she was impressed.
Well, how many
It's the goal.
Yeah.
I told the girl.
All right, well, great job, everybody. Dr. White, did you have any questions?
I do not, but I very much enjoyed your presentation.
Oh, thank you very much.
Yeah, I wanted to mention that, the Sunho's team, Dr. Lim's team has been great, the students as well, and it looks like they've not only been, advancing their own research efforts, but they also learned some lessons from throughout the summer, because I remember Russ had pointed out something about their color scheme and their visualization, and I noticed today that it was a lot more uniform, so they really are... they learned a lot and they applied it right away. So well done.
Awesome.
Thank you very much.
Thank you.
All right. Well, thank you all.
All right. Thank you very much. All right.
Thank you.
Take care.